Good morning, everybody. Welcome to the sorting and packaging panel that I'm happy to be the moderator. Well, I think this is the sorting and packaging area is an area where we have seen a lot of innovation. Not only the last years, but continuously innovating in the way we are sorting and packaging our fruit. And while also improving or having less impact on the fruit and having less bruising, which is one of the things that is crucial when packing and fruit for the fresh market. And it's also important when we integrate a growing and harvesting and packaging system in which we want to get to the fresh market, especially from countries like Chile, where we grow and export blueberries to parts of the world, every part of the world, and we are far away from everywhere. So this is very sensitive for our country, and I guess for every grower also here in the US. I would like to introduce our speakers today in this panel. I don't have the fancy introductions that Mark has, but I will leave some more time for our speakers to make their own introductions. So we have, first of all, Marco Castagnoli from Unitec. Then we'll have Jeremy Barros from MAF Industries, Marco Mazzaretti from Key Technologies, Eric Horner from WICO, and then Amish Kay from BBC Technology. People from Tombra excused their participation yesterday, but I think that Amish will have something to tell us about the relation of BBC and Tombra from now on. We will have 10 minutes each plus two minutes. The watch will be showing the first ring at 10 minutes, so we'll have extra 2 minutes whether to finish your presentation, whether to accept question from the audience, and in the end we will have a panel discussion just as we had in the previous panel. So with further ado, I would like to introduce Marco Castagnoli. Thank you.
So good morning, everybody. My name is Marco Castagnoli from Unitec, and today I have the pleasure to talk to you about what we can do for blueberries. Unitec, as probably some of you know, is an Italian company that is working on over 35 different kinds of fresh fruit and veggies. And at the moment, we are present in over 6 countries in the world. It's a family-owned company, and this is one of the main things that we like to emphasize. Everything that we manufacture is 100% built in-house, starting from electronic to mechanical, including automation and traceability. So this helps us to have full control of every project that we develop. Our background comes from working with other small products and items like, for example, cherries, where at the moment in North America we are leading the market, and let's say, I would say also at this point worldwide. We have been so far the first company to introduce the concept of singulation to inspect each individual blueberry compared to previous technologies that were based on different concepts. So this system that we name Blueberry Vision allows us to determine electronically size, color, and quality of blueberries, whether external or internal. Everything started for us in blueberries just 5 years ago, and as of today, I can say we have our lines running in the most relevant production areas of blueberries in the world, such as Europe, South Africa, South America, and of course North America. As I said, we build customized turnkey lines, so for us every project is different, and we put we always try to put innovation in everything that we do, to try to gain every time something done a little bit better. And so for me to, in 10 minutes, to explain what we do in details would be practically impossible. So we prefer to let our Blueberry customers and their impressions to talk in behalf of us and tell you what we can do for blueberries.
Esta temporada, a ver, quizás la compra de la máquina fue un poco premonitoria, porque este año hemos tenido un par de eventos climáticos importantes que si no hubiera sido por la máquina, esa fruta se hubiera perdido. Este año ya de la cantidad de fruta que hemos pasado hasta el minuto, un 15% de la fruta es fruta que si no hubiéramos tenido la máquina habría terminado como IQF en industria. Y eso también es un gran beneficio el poder rescatar toda la fruta que nos entrega el productor, quien finalmente es quien necesita que se exporte su fruta. Los productores que tiene Coyipulli son los socios de Coyipulli. Entonces son ellos mismos los que aprobaron la inversión en la máquina. Y hoy día el comentario unánime es que es la mejor inversión que hemos hecho en mucho tiempo. Estamos muy satisfechos con el resultado, con la confiabilidad, lo voy a volver a decir, no solo de la tecnología, sino que del equipo Unitec. Una máquina por sí sola, sin un equipo por detrás de apoyo, no sirve de nada. Porque si la máquina falla y no hay quien venga a arreglarla en forma rápida, la máquina no sirve de nada. Para nosotros esto va a significar una revolución en la industria del arándano. De aquí a un par de años más, si no es antes, el que no cuente con esta tecnología va a quedar fuera del negocio.
Con el Blueberry Vision nosotros básicamente eliminamos la selección manual, ya no hay gente seleccionando arándanos. Mi visión particular es que nunca la ha habido, y aunque tú pongas 20 personas en una línea no vas a alcanzar a tocar más del 5% de los arándanos. Al ser los arándanos una fruta tan chica y tan difícil de ver, cuando ves pasar millones y millones de arándanos frente a ti, no hay ninguna posibilidad de que selecciones algo. Por lo tanto, las cosas más groseras se podían sacar, pero realmente si tú tenías una fruta blanda o una fruta con algún detalle difícil de detectar con el ojo, era imposible hacer una selección. Entonces hoy día realmente estamos seleccionando arándanos, antes no seleccionábamos. Y eso te lleva a tener un producto superior, un producto estable, un producto homogéneo. Independiente que tu fruta venga con un 10, un 15, un 20% de fruta mala, tú logras un clamshell, una presentación del producto para el consumidor final consistente y estable. Y eso es lo que finalmente queremos enviar a nuestros clientes para que, si la experiencia de consumo es mejor, se repita la compra, se repita, digamos, ojalá la preferencia por nuestra marca y eso nos genere un mejor negocio en el largo plazo.
La máquina esta tiene una gran ventaja, que es nadie toca el producto, y eso es súper importante. Desde que la máquina hace el volcamiento de la caja con la fruta hasta que la fruta está dentro del clamshell, nadie tocó la fruta. Tenemos una cantidad de gente bastante inferior a lo que teníamos el año pasado y con un mucho mejor control de la gente. Se ve un packing limpio en términos de visibilidad, de gente, la gente que está alrededor, que está caminando, que está haciendo, y todo fluye en una forma expedita. La gente que nos ha ayudado desde la instalación en adelante ha sido algo muy grato y sabemos que levantamos el teléfono y está la gente acá para solucionar cualquier tipo de problema, no básicamente problema, dar una solución a lo que estamos haciendo. Cómo se desarrolló la cereza en los mercados más exigentes, en este caso China, yo creo que en el tema de los arándanos debiéramos tener un comportamiento muy parecido o igual a lo que estamos teniendo, a lo que fue con la cereza. Hoy día la tecnología Unitec le dio un impulso a la cereza en el mercado asiático y que yo creo que va a ser lo mismo en el caso de los arándanos con esta nueva tecnología. Creo que estamos 2, 3, 4 años adelantándonos a lo que viene en el futuro de los arándanos.
I work for Agriculture Capital. We're an investment fund that's focused on food production, and our key focus is on sustainability and building vertically integrated food systems. We're in kind of 4 key crops: blueberries, hazelnuts, citrus, and table grapes. And obviously, working with Unitec's been a big part of our blueberry strategy going forward. Being able to machine pick for the fresh market is one of our kind of key strategies going forward. Blueberries are so delicate, and they get bruised even hand picking, but machine picking them tends to bruise pieces of them every once in a while, and it's something you can't actually see with the naked eye. We were really excited about the idea of seeing interior bruising, and we're actually very focused on machine picking blueberries, and so being able to sort blueberries in a very exacting way and be able to see bruising was a key feature of why we decided to go with Unitec. With this machine, we're getting data on every single blueberry that goes through it. Understanding the farm, understanding marketing, and understanding the varieties as well for continuous improvement is really a big part of why we decided to work with them. I think the Unitec helps us differentiate ourselves from other producers. The first one being quality and consistent quality, regardless of what's happening during the season, what the weather is, being able to really sort out things that aren't up to a really high standard in terms of quality for fresh pack. One of the pieces that's really attractive to us is being able to sort by size as well, and to be able to make uniform pack sizes. Our decision to work with Unitec, it was influenced by our desire to export, being able to get a really high quality pack so that there's extra legs on the fruit for obviously long journeys as well. This allows us to say okay, we know this fruit's gonna have a problem going forward, and this is one that's gonna be better in the frozen market. It's in great shape now, and so we can freeze it and it won't have to sit out and deteriorate over time. We know a lot of where we want to go, a lot more of how efficient we want to be, what markets we want to get into, and where there's room for improvement. And I think the Unitec and to be more specific, the capability of being able to sort the fruit to that high of a level is a key part of making all the rest of that work. We're really excited about the future and what we're doing in blueberries, and I think we feel really pleased to have the relationship with Unitec.
自从釜山 用了这个机器了之后，我们蓝莓的销售的不管是价格还是我们最终的利润，都是最终的回报都是比之前没有用过机器的要好了很多，至少有30%到20%的提升。
我们现在扶桑蓝莓，它是改用了这个新的技术之后，非常受欢迎，质量非常稳定，然后销售价格呢也一直是处于市场的领先位置。
消费者目前对中国的消费者啊，目前对这个健康的这个理念非常深入人心。蓝莓在未来一定可以像车厘子一样的受到消费者的喜欢。
So basically, this is what we can get with our technologies. These are some examples. Then I didn't mention, but we are an USHBC member associate. So on top of questions that you might have after this short presentation, we will be here for the rest of the week. So if anybody has more questions or wants to talk more in details, we will be out with our desk. And we invite you to join the association as well. So thank you very much.
Thank you, Marco. We will definitely have our panel discussion after the presentations. Well, I would like to call Jeremy Barros from MAF Industries. Thank you.
So good morning, everybody. My name is Jeremy. I'm French, as you can tell by the accent. So if you don't hear or understand me clearly, just let me know, okay? So MAF Industries, we are a French company, but a worldwide company. Our mission concept is to provide customized, meaning that we don't just provide standardized equipment. We customize to your very need as a grower. So we want to make it a point to make sure that it fits your need. Innovative, we invest a lot of money every year as a company to develop innovative solutions mechanically, electronical solutions that we develop in the US. Turnkey, so we provide the full solution. Again, we consider ourselves as solution provider, not equipment provider. So we do it all from A to Z, so the design, installation, electrical, all included. In close partnership with our customers, so we stay behind our solution. Service is very important, especially in the US compared to other parts of the world, and we acknowledge that and we stay behind our equipment. To guarantee a short return on investment, a solution itself, it can be the greatest and latest technology. If it doesn't meet your financial requirement, it's pointless. So we take that into consideration as well when we provide you our solution. So we are a group of 15 subsidiaries, 1,000 employees. We are the world leader in the fresh fruit and vegetable sorting, grading, handling solutions. In the US, to talk more specifically about this area, we are based out of California, where we have our workshop, and we have also a workshop and sales office in Yakima, Washington. We do the turnkey solution from the dumping to the palletizing solution, all the way down, going through the treatment, precising, quality sorting. We're going to go through step by step in this presentation. And also, very important, traceability. We also take into account the USDA regulation, which is very specific to the US compared to European countries in terms of design, sanitation, cleaning. All of that is included in our design and solution. Very important. So we can handle on our solution blueberries and cranberries. We adapt our carrier to the fruits, but the base frame remains the same, meaning the mechanical parts and the electronics is basically the same, and we adapt our program and our carrier for those very fruits. So this is one of our concepts for the berry way, so the blueberry solution, the berry way. Just to give you some more details, it's more technical presentation, but we have a speed of 2,500 bicons a minute, so potentially at 7% cup filling rate. Considering an average weight of 1.6 grams per piece of fruit, we have about 375 pounds an hour per lane, meaning that we go from 2 lanes to 24 lane machines. So to give you an example, a blueberry sizer berry way, an 8 lane will grade about 3,000 pounds an hour. So that gives you a potential in terms of peak capacity, average capacity as a grower that you do on a daily basis, what it will require in terms of number of lanes for our solution. Mechanical equipment, so like I said, we take into account in our design food safety, GMP standards, also the North American Blueberry Council requirements and standards into account. At the design stage, we design, manufacture, and service all of the equipment in the US. So we are very into these requirements. So as you can see, this is the infeed of the machine, so with V-belts that we singulate the fruit. We transfer the fruit with minimized drop, 1.5 inch at most, because we know handling is very important. We don't want to bruise the fruit down the line. This is the camera box where the magic happens. So we take 56 pictures per piece of fruit individually. We are not grading, bulk grading. It's individual piece of fruit again. So in different wavelength, color, infrared, near infrared, to detect different defects that you can or cannot see by the naked eye. And then we have the ejection by air blast, so to be also gentle to deliver on the belt to go back into a tote or to clamshell filling machines. Electrical, so we are compliant with NEMA, IP regulation. We are UL certified also, very important in the US and North America. Food safety is very important. Again, like I said, we take this part into account not only by using stainless steel material, but in the design of our equipment. We take into account the latest USDA release to have accessibility on our machine for maintenance, cleaning, all of that, we take it into account from the very early stage of our solution, all the way down to the service. We have also an onboard cleaning system. That means that we can clean our machinery as, for example, during the production, you have a break of 10, 15 minutes. You can run a program that's telling you, okay, I'm going to clean the machine, so that it's not eliminating your cleaning procedure at the end of the shift or at the end of the day, but it's minimizing the buildup and minimizing the damage on the fruit that you can get down the line. Some more certifications again. So we have two systems in terms of electronics to go along with the mechanical part. The electronics is a flow management system, which we call ORFIA, which basically is a program where we put all the threshold and the sensitivity of the system to grade your blueberries. To say, okay, this is the beginning of the season, I'm gonna have this program, middle of the season, end of the season, or if I'm running Dukes, Snow Chaser, you adapt the program depending on the fruit or the lot that you're running, so that you are always taking the best out of the system in terms of accuracy. If you do domestic market, if you do local export market, you have to adapt the system accordingly to have the right accuracy, because you don't want to have more than 3% of defects in your pack out, so this is taking it into account. Then we have, going along with the flow management system, we have the image processing system, which is basically doing the quality sorting. And like I said, we are using hyperspectral cameras, meaning that we browse the full spectrum of the wavelength in terms of defect that we can sort out of those wavelengths we are using. LED lighting indirect to avoid any shadow and have the best and great accuracy on the image we are taking. 56 pictures per piece of fruit. I know that's a lot of information, but that's just to show you the full potential. Diameter, color, and quality sorting. So diameter, color, that's not an issue for anybody in the industry, but quality sorting, especially for the things that we cannot see by the naked eye, by using infrared technology that we are using in different wavelengths, this is something very important. To detect especially the kicker when we started developing this solution 4 years ago was softness detection, bruising detection. Average softness, but also soft spots like you can have at the bottom, at the bottom of the berries. You can have a very nice piece of fruit, but a soft spot that can ruin your pack out and basically get your lot rejected. So you don't want to have that, and we are able to fine-tune this softness detection by using our technology. So I talked about softness, flesh, bruising, dehydration also. So we are using basically, in terms of electronics, artificial intelligence, machine learning, which is basically used by the big guys like Google and these kind of guys for autonomous driving, but applied to this industry. So we are at the cutting edge of technology. Again, we are investing a lot in this to develop the greatest and latest for your fruit. Some of our references, so we have, I mean, like most of the guys, so the references in Peru, in Chile as well. So for example, this one were 16-lane sizers. This is the Chile references that we have also with the picture here. So you can see the 16-lane as well and the camera box where we are doing the grading. Spain as well, so we are also present in Europe. California, this was the very first machine that we installed in 2017 in the US. And it was more like a prototype platform to develop a solution where we were able to increase the accuracy of the system from 85% to 95+% in terms of quality. And the very first one, so it was a very good surprise. Oregon, we have a 24-lane machine in Oregon that's getting reconfigured to optimize the use for the next season. Washington State as well, we have an 8-lane machine. Our 8-lane machine, the advantage of that is that we can reuse existing equipment at the in-feed. I will not give any names, but the traditional ways of sorting, you can reuse the in-feed and replace the grading manual system by automatic system. So basically the added value with MAF, when we started developing this solution, the target was labor saving because like everybody knows, labor shortage issues, minimum wage issues. So it was the very beginning of the development. Turns out that it's not where our customers are saving most of the money and most of the headaches, it's production. We are saving production because we have an accurate system. I mean, we are talking about over 95, 98% accuracy of our systems. So we are saving a lot of production compared to other technologies that traditional suppliers are providing. Better control and quality on sizing. High versatility, meaning that you can do pre-size or you can do commit to pack configuration. It doesn't matter to us, we can do both, depending on your operations and what market you address. Less handling on the fruits, so less drops. We minimize the drops. That's one of the things we improved for the last few generations of machines that we produced. Reduction of labors, of course, and complete turnkey solution, including traceability, which is very important, again, in the US. And we stay behind our equipment also in terms of service. Local service from California, from Washington. We have agents also in Michigan area on the East Coast. So we are present mostly in the US, but also in the other part of the world like Chile, Peru, and Europe. So that's it. Thank you. Any question? Okay. Thank you.
Thank you, Jeremy. I would like to call Marco Mazzaretti from Key Technologies now.
Oh. How do I? Ah, okay. Oh, let's go back here. Okay. Hi, good morning. So you're getting quite a selection of international accents this morning. And mine will be Italian, just like the first presenter. My name is Marco Azzaretti, but I am here representing a company that is based in the US, which is Key Technology. So we're based, headquartered in southeastern Washington State in Walla Walla, Washington, for those who are familiar with that area. On a personal note, I'm originally from Italy. I spent quite a bit of time in the food industry. I also happen to be a local resident in Salt Lake City, so if there's any skiers out here that are going to take advantage of the location of the meeting and would like some tips, you can see me afterwards, in addition to questions about the presentation. So Key Technology, we manufacture digital sorting equipment, as well as process systems and conveyors for the food industry. And we have obviously a special focus that's application driven. And here's a selection of Blueberry customers that have entrusted us with utilizing our technology as part of their processes. As has been discussed already also by some of the previous presenters, this technology is quite focused on an application basis. And so we have a sort of a flexible engineering platform that allows us to tailor each system not only to each product application, but also to the specific requirements of every packer and every grower, because we realize that really there are very sort of individual, unique requirements that each customer has, and our technology needs to be flexible enough to be able to deliver exactly the right type of solution for that particular grower or processor. So the focus of today's discussion is on packing fresh fruit, but we also develop systems that are tailored for IQF applications for blueberries as well. And we have experience working both with cultivated berries as well as wild berries. The selection criteria for the equipment is very flexible. At a high level, we have the need to eliminate all foreign materials, of course, from the product stream. But then, of course, is the the more sort of flexible aspect of delivering the desired grade to each processor. And this is where things can change from customer to customer, and where the machine needs to be flexible in its configuration and in its ability to deliver at the right time exactly the right type of grade that is required by your customers. And that can change depending on the time of the season, depending on the customer and the markets that you're serving. And based on this recipe-driven approach to managing the sort, we can make sure that we optimize delivery of exactly the right type of grade that your customers are requiring, but also at the maximum possible process yield. Because, of course, from a profitability standpoint, from an operating perspective, the objective is not only to deliver the right quality to your customers, but also to do that through a process that maximizes product recovery and increases process yield. This is what conceptually our equipment looks like, and there is an important distinction between the type of sorting equipment that we supply and some of the singulated sorting equipment that you've heard about from
the prior presenters, because in the case of our optical sorting systems, the fruit, the blueberries, are conveyed through the inspection process in bulk. And see if I can use a pointer here. They're conveyed through the inspection process in bulk, and they're guided through the detection area by a chute that's optimized to ensure gentle handling of such a precious and fragile product, obviously. And then the berries, each item in the product stream is inspected from both sides. And then we're using a precision air valve system to deflect away from the good product stream either foreign materials or fruit that does not correspond to the quality grade that has been determined by you to be the target grade that is in the sort recipe. And using this type of equipment, we can manage to split the product stream in 3 different ways. And typically, one sort stream is reserved for ejecting foreign material and unrecoverable product. And then the other 2 source streams can be used to separate 2 different grades of good product. So what I'd like to do now is step through the system and talk about where technology innovation is happening, and thinking of our current equipment technology, what is new, and what are some of those new technical capabilities that are available on the equipment today, and what that means in terms of potential value creation for your process. The first area of technology innovation in our systems is the detection sensors themselves, with respect to their ability to inspect not only in the visible range, so inspecting for properties on the berries that are externally visible, such as obviously color, size, shape, but also using infrared spectroscopy and multispectral and hyperspectral imaging, be able to utilize infrared inspection to be able to detect properties that are not immediately visible, such as subsurface bruising in fruit. The technology continues to evolve. On our systems today, that technology is better both in terms of its spatial resolution, which means that all else equal, those defects that I described, we're able to detect them as they get smaller and smaller compared to before. And the technology is also evolving with respect to the quality of the signal that's generated from those sensors, in terms of being able to clearly differentiate between what is a good berry, what is a defective berry, and what is a foreign material contaminant that doesn't belong at all in the product stream. To the point of developing an accurate, let's say, digital fingerprint from the sensors about the type of material that we're looking at. Another innovation in our current equipment is the ability to fuse the input from multiple sensors at a pixel level. Different sensors are good at detecting different types of properties. Silicon-based cameras are very, very good at detecting color differences. Hyperspectral imagers, which can operate both in the visible range but also in the infrared range, are typically utilized in the latter to look at subsurface bruising, other types of conditions that are not immediately detectable by looking at the outside of the berry. On our machines, we combine different sensor technologies, but we do that not just by looking in time and space with 2 different sensors at the product stream, by actually training multiple sensors at the same pixel level. And that allows us to get a very, very rich set of information about that image pixel of information that we're looking at. And that additional information is what allows us to make a more informed decision about, again, what is a good berry, what is a defective berry, what is foreign material. When you look at assessing the quality and the performance of any sort process, there's really two main criteria. One is, of course, am I getting out of the product stream the bad fruit, the foreign material that I don't want in my product stream? But then, of course, the other aspect is how efficient am I in performing that sort? Sorting systems are already, in many cases, very, very effective at cleaning the product stream and delivering the type of grade that you're looking at. But in some cases, that performing a very, very tight sort typically results also in inadvertently getting out of the product stream good product, which is, what you don't want. Ideally, you want a perfect sort, which means you only get out of the product stream the bad berries. But as you get to finer and finer defects, those start to look very, very close to the good berries. And therefore, the evolution of the technology is not just in removing poor product more effectively, but also in doing that and in the process sacrificing very, very little to no good fruit so that your yields can stay high. And to that point, we've talked so far a lot about sensor technology, but so it's one thing what the eyes of the machine see, but then of course the rest of the sort is physically getting out the right product. It's not just enough for the machine to be extremely accurate at seeing defects. It also has to then physically perform the sort. That is, targeting an object for removal from the product stream and then actually getting it out without getting out any good product that might be lying around it. And this is also another area of technology innovation where the systems are getting smarter and smarter at developing ejection techniques that are aimed at getting out of the product stream only the bad fruit and not inadvertently sacrificing or knocking out any good fruit that might be lying nearby. And again, this goes to process yield and good product recovery. The last point I want to make about technology evolution in our machine space is this area of information analytics, traceability. Optical sorters are extremely good at gathering through the very sophisticated sensors that we have on our machines a whole array of information that goes even beyond what the machine needs to perform the sort. All that information is really accessible and can be tapped into it. And the systems are getting better and better from an integration standpoint at providing that information to you in whatever way is interesting or accessible to you, either offline in database files or in Excel files. But more and more we're seeing some of the more sophisticated customers integrating the system within a larger SCADA or MES framework where they can really make the most of all of the machine that the sorter is collecting. And utilizing that information, not just to perform a good sort, but also to get insight about what is happening upstream with regard to the fruit that is coming onto the system, and then to make business decisions about the quality of the fruit that's being provided from different sources, from different fields, and so forth. So think of this technology not just as optical sorting technology. Yes, it is a sorter, so it has to be a good sorter. It has to do a good fruit selection, but also think about it as a true information center for your business and think about how you can harness that information to drive better business decisions for what happens upstream. That's a presentation, and I'll look forward to questions during the Q&A section that's upcoming. Thank you.
Perfect timing, Jeremy, thanks. We'd like to welcome Eric Horner from Wico now, probably a more natural accent.
Thank you very much. Glasses. Yeah, thank you again. I'm here to talk about advancements in optical and sensor sorting for mechanically harvested blueberries. So I recently heard this: what is the most important thing in our industry? I heard it and I thought it was very fitting for what it is we're talking about today. And that is provide the highest output at the lowest cost while achieving the highest quality. At the core of this discussion is how do we eliminate labor and sort the fruit more gently and efficiently. I think I'm supposed to do this. Ah, there we go. So what does it mean, the highest output? Go as fast as we can using sorting technologies. How do we achieve the lowest cost? No labor and cost-efficient electronic sorting technologies. And finally, how do we achieve the highest quality? Maximize advancements in sorting technologies that are gentle and accurate. So we're going to talk about two technologies today. First, the camera, the lights, and then sensors, and then finally, the material handling, and then we'll tie it all together in the end. Pardon me, I'm kind of nervous up here. This is terrifying. I don't know why. LEDs are probably the most widely used light sources for digital line scan imaging cameras. The benefit is that they're relatively inexpensive, long-lasting, and available in an ever-increasing spectrum of light sources, including the non-visible spectrum, which is important for our industry in removing soft berries. As the light sources become brighter and more varied, you can develop software that provides more options for the user. As an example, higher resolution cameras for size sorting and very small defects, or better optical soft sorting capabilities. You can incorporate more computing power for data processing of the images and design software around those advancements. Sensor. If you're not familiar with sensor sorting, basically you have electronics embedded in what looks like a piano key. When the berry makes contact with that sensor, it can determine if the berry is firm or soft. When this technology was introduced several years ago, we knew that there would be a need for this in mechanically harvested fruit. We love sensors because not all soft fruit is created equal. Current camera technologies require that the internal color change take place for the camera to identify that it is soft. So how long does that take? Well, it depends on many factors: temperature, variety, among others. Take any camera technology and none of them can see every type of soft berry. Touching one or even two sides of every berry provides an exceptional level of sorting. This is, in my opinion, the most significant development technology for increasing throughput. So the next slide here, I believe. Well, there it goes. Okay, this is just an example of a tactile sensing machine. The berries make contact with those blue fingers, and basically it's very, very fast, very efficient, very gentle. So how can we make this whole process even more gentle? We need to rethink the whole cleaning line, like no berry impact transitions between pieces of equipment, minimum drop cleaning lines. Engineers are also working on the overall drop while increasing the angle of the sensor, the blue sensor there. If you decrease the angle of the sensor, there's less impact on the berry, and you also maintain more bloom. Currently, there are a number of packing facilities that are using two sensor sorters in tandem to achieve the higher quality. The camera and electronics are nothing without the proper material handling. In fact, I often say it's more important. Free fall style sorters inspect the product midair. Benefit is you can incorporate two cameras to see two sides of the berry at the same time. Rejects are removed in midair, which is efficient. Downside is that there's a drop for the good berries, but every effort has been made to ensure very gentle handling of the fruit during this process. Okay, next I'd like to show a video of, so this is an example of multiple sorters being used in tandem. In this configuration, we have two soft sorters and then two color sorters. Actually, I think that, Oh, so, no, pardon me. The video is gonna show 2 soft sorters, 2 color sorters. We realized later that it was better to put a color sorter, 2 soft sorters, and a soft sorter, a final color sorter on the end. So this is doing mechanically harvested fruit at an input rate of 14,000 pounds, packing 10, 11,000 pounds directly into a weigh and fill. I apologize for the quality of the video here. We didn't realize that we would be doing this speech when we took the video, but it gives a very good example of what is possible. Okay, so clearly mechanically harvested fruit, up the elevator to the blower. We estimated that the green and red accounted for about 20% of the coals coming out. Okay, so this is the first soft sorter. Now, soft sorters will remove green fruit when you expect them only to remove blue fruit, and that's largely due to stems or very light berries. They provide the same signal that a soft berry would. So for that reason, we moved the color sorter to the front. So this is the second soft sorter, and then the very first color sorter. So you see a very, very high rate. This machine was set up to focus largely on green, some red, and optically soft as well. Still the first color sorter. In a moment, we'll take a look at the final color sorter, and you'll see that it's focusing largely on green, or excuse me, red. Next, there's a short inspection table on this line, but there's no labor. So this line was 14,000 pounds input and no hand labor afterwards. So here is a before picture. These are still shots of that same video you just watched. And then here's what the final product looked like before going directly into the weigh and fill. So very fast, very efficient. Okay, so moving on to another material handling and sorting technology. Lane sorting or cup sorting is another option in which every berry is in its own cup or in individual rollers. Benefit is that you can roll or spin the berry 360 degrees and create categories for the fruit. Downside is that it tends to be very expensive, significantly slower than other methods. However, it provides for total elimination of hand sorting. Okay, so what I'll show next here is a sneak peek at our most ambitious engineering project to date. It incorporates many of the advances I've already discussed: higher resolution, more computing power, the ability to size and categorize the berries, and of course an all-new material handling method. So this is just going to be a slow motion video. So you notice the cups are in a down tilt position right here, and the berries will be fed right through here in a singulation lane, and then they fall to the back of the cup. So what this does, one berry per cup. It's a very gentle transition, and then as it reaches the field of view of the camera, the cup tilts again, rolling the berry one time, not spinning it, maintaining bloom. And multiple pictures are taken in during that process. And then as it spins around in a 4-foot wide circumference, it's dumped in, those berries they fall into separate categories. So this will be something we'll field trial this year. Considering these technologies and the potential advancements, how do we get the highest output at the lowest cost while achieving the highest quality with mechanically harvested fruit? One option: incorporate multiple technologies. Perhaps you use a traditional cleaning line that includes double color sorters and double soft sorters. Another option, you use one of the lane category sorters, but incorporate traditional free fall sorting and soft sorting into the cleaning line. This also eliminates hand sorting. Field trials are set to begin on that this year as well. There are many possibilities, but we need to be smart about how we spend our engineering time because the market is changing faster than ever. 12 years ago, global production was at 400 million pounds. Now it's estimated at 1.5 billion. The packers must be smart on how they spend their money so they can achieve the most important thing: highest output, lowest cost, highest quality. Thank you.
Thank you very much, Eric. And our last speaker for this panel is Hamish K from BBC Technologies. I guess some different accent here also.
Hi everyone, New Zealand accent for the mix now. It's really great to be here today. It's really cool that we can be part of this conversation. Obviously there's some pretty big challenges in the industry that everyone's facing with regards to labour. The obvious one that everyone's talking about is the cost of labour, but there's a few other subtleties and aspects of labour that really affect you as well. So one of those is the availability of the people. For some of you, it's a lot harder to actually find that labour. This is seasonal work. People have to be hired and brought back year after year, retrained, and it creates challenges for you. Keeping the best people, you really need to keep them all year round if you want to keep them, build and grow with them. Another aspect of having people in your pack house is that there's quite a lot of other costs associated with them other than just their salaries. It's bringing in uniforms, facilities for them, infrastructure, place to wash your hands, place to go to the bathroom, place to store your things, eat, hair nets, and all the food safety stuff that goes along with that as well. And every person that you bring into your pack house is a potential risk to the food safety of your operation as well. Beyond that, however, though, the real challenge with labour, in my opinion, is the consistency that people are able to deliver. But from person to person, their perspective of whether a fruit makes grade or not, how precise that is, it can vary, and even within the same person, that can vary throughout the day. That one person may have a different opinion in the afternoon of exactly whether that fruit makes grade or not. So when you have people on an inspection table inspecting your fruit, that creates a lot of challenges for you. So what are we going to do about that? Well, firstly, I'll tell you a little bit about BBC Technologies and how we're thinking about the solution. We come from a long history of blueberry pedigree. Greg and Alison Furness, who many of you know, started farming blueberries back in New Zealand around about 40 years ago. They were pioneers down there. And eventually they morphed it into a technology company as well about 20 years ago, where we've been really highly focused on blueberries. That's been our key area of interest as a company. Beyond that too, we've had a lot of machines installed around the world. We've got a lot of your customers here, and we're working with people all over the place to get their input and understand what are the challenges everyone is facing, and what can we do about it, how are machines performing, taking feedback from that, incorporating it into new ideas and new designs. Really key centre stone to the development that we're doing is we have an internal berry science division. The focus of this division is to really investigate the blueberry and help push the industry forward. And what we're doing to do that is that we're gathering a really extensive database of samples of blueberries. We're sampling blueberries from different crops, different varieties, different seasonal conditions. We're bringing them into the lab and we're taking really detailed information about every single blueberry and putting that into a database. And we're using that information about blueberries to help inform our design of the machinery and make sorting decisions. So how have we gone through and factored this into some sort of product? The idea that we've had here is to start from scratch. Think, okay, we're focusing on blueberries. How can we design a machine specifically for purpose that best meets the needs based on all this input information that we've gathered over this time? So what we've decided to do with this machine is we've created a machine that's specifically for this purpose. It's not an adaptation of a machine from another commodity that's been adjusted to suit for blueberries. It really is designed just to focus on blueberries, built from the berry up. To give you an example of what we're trying to do here, we're trying to capture a really high level of information about every single fruit that comes in through a sorting line. We're looking at every surface of the fruit, taking a lot of photos in really high resolution, gathering at different light wavelengths, and really getting as much information about every single blueberry that comes in. And then we're able to sort that across into several different output streams. So to give you a really simple idea of how that might work, you could have 4 different grades that you're sorting to. The idea being here to get the maximum value from each blueberry that comes in, not just rounding down to the lowest common denominator, but getting as much value for every blueberry that you're packing. So you could have simply a really high quality, firm, larger fruit that's going to your export grade, getting the maximum quality. You could then have a slightly more regular fresh pack grade, for example. So just everything else that wasn't quite firm enough for that export grade, or not big enough, for example. Then you could have your grade A for IQF, and then everything else that didn't quite make the cut could be going through to juice. You could then, if you wanted to, for example, go even further and split your IQF fruit into grade A, grade B, grade C. The idea here being, let's take your fruit that's coming in and get as much value for every single fruit as possible. Let's round it up rather than round it down. So by doing this at a really high level of precision, we're coming back to this original challenge that we're facing, and we're taking the manual inspection out of the equation. So what does this look like for us? The machine that we've got so far isn't just a prototype. It's not something that we're recently testing. This machine so far, we have over 50 of them installed around the world. We've got customers who are now in their 2nd season with them. We've got customers who are repacking all year round. People who've packed with it for 1 season, they've come back and bought more for their next season. We've got quite a few extra machines coming into North America for this season, and our momentum really is continuing to grow. We couldn't have had this level of success without people really getting value from the product. One of the things that's really driven our design process has been trying to keep the machine really physically compact. We've tried to keep it as similar to a traditional packing line that many of you are familiar with, the colour sorter, soft sorter, inspection table, and try and keep the pounds per hour output similar to that as well, or as good as possible, so that you're able to integrate these new machines with your existing packhouse infrastructure. Building packhouse space is not cheap, so we're trying to do as much as we can to adapt with that for you. The other benefit of a physically compact machine is that it's cheaper to build. We have less material costs, it's quicker and cheaper to make, and it's cheaper for us to ship it out and get it to you. That allows us to give you guys machinery at a more achievable price point to be able to get into your technology operations. So where are we heading to from here? As Andres referred to, as of yesterday, we've actually just been acquired by Tomra. This is a pretty exciting opportunity for us because it enables us to build on our existing capabilities while bringing in the really strong international networks, global service abilities that these guys have to really be able to strengthen our operation. BBC Technologies is going to continue as BBC Technologies, but with that extra level of support to be able to really drive home a high quality level of service and give you that really good responsiveness that you need on a global scale. So thank you very much for your time, and it's really been great to be part of this conversation. Any questions?
Thank you, Amish. I would like to call the other speakers to the stage to receive the questions from the audience. Please.
Hamish, I'm Tom Bodke, Blueberry Grower from Michigan. And the question I have just related to the new information, and maybe I don't know how far along in the process, but obviously Tamra had their own sorting division. Are you going to operate those as separate divisions, or is there going to be an incorporation of the technologies and the sales of those products?
Yeah, you're right. Obviously, this is pretty new news, so we're still figuring that out as well. But at the moment, BBC will continue to operate as BBC, and Tomra will operate as Tomra. So over time, those are likely to potentially merge, but for now, we'll continue as we are.
Hi, Scott Williams, Spencer Technologies, West Lafayette, Indiana. And this is a question that anyone in the group can answer, but for the optical sorters, what is the resolution that you are getting for your camera systems? Like how fine a scale?
I'm not actually sure as to exactly how fine we're getting. But we're using really high resolution cameras, and we're able to go down to a pixel level scale on that. So you can interpret that we're getting very precise information about the fruit based on that. I don't know if anyone else wants to.
Same, let me say, we don't base our performance just on the resolution of the cameras. So it's not, to be honest, a key factor to determine whether if equipment is efficient or not. So it's basically, I don't have the exact technical answer, but it's what we want to transfer is that is not the information that makes the difference.
Yeah, I mean, I totally agree with what has been said. One thing I would like to add in our case, we are using a single camera, hyperspectral camera that's browsing the full spectrum of the visible and invisible. That means that in terms of resolution, considering other technologies that are superposing different cameras per wavelength to be able to detect all the defects with, let's say, a set of 4 or 5 cameras, we are using only one camera, so we are not pre-processing the images, so we are keeping the raw resolution of the image that we process. We don't lose resolution because we are not pre-processing the images that we are taking. That's one thing on our side.
Excuse me.
Our image resolution is 1/16 to 1/64th inch pixels, depending on the product.
Yeah, I don't know that I have much to add. I don't know to say that the spec is really, you know, as others have said, not necessarily critical. If you have a pixel, first of all, different sensors will have different levels of resolutions. For example, you know, in silicon-based cameras, typically the spatial resolution of the sensor can be much higher than, let's say, on a hyperspectral imager. But then, of course, the type of data that you get from a hyperspectral can be more interesting based on the ability to select bands of interest throughout the light range. So if you see that a camera has a pixel size, let's say, of 1 millimeter or 0.5 millimeter, that also doesn't necessarily mean that that is the size of defect that you're going to be able to detect, right? So if that was the reason for the question, you know, if I tell you our camera is a 0.5 millimeter size, you know, that doesn't mean that you're going to be detecting a defect that is a ½ millimeter small. Typically, the actual performance resolution of the sensors, it's higher than the spec. So you really have to judge the system based on its measure performance from the sort rather than focus maybe too much on pixel size.
I have a question. Mark Hurst from Oregon. Marco number 2.
Me or
yeah.
Okay.
Key technology, yeah. My question is, in your talk, you were talking about being able to eject 2 different ways with a single nozzle. Did I understand that correctly?
Right. So so I think maybe it was you, Eric, that was commenting on the difference between singulated sorting and sort of bulk sorting. Obviously, with singulated sorting, a lot more real estate, but you can have a significant number of drops depending on product size, product grade. When we convey the product in bulk, we can do that in a smaller system with much higher capacity, let's say per square foot, and but we are limited to three sort ways. We can split the product stream in 3 different ways, and on systems where we use air ejectors, that is done by using 2 separate banks of ejectors. So effectively, the good product will travel through and will not be fired upon by any one of the 2. And then if you have, let's say, a secondary grade, that will be taken out by one bank of ejectors, and then let's say trash or FM or secondary product that goes to maybe juicing or some other recovery, then will be taken up by the 3rd ejector. So we can manage 3 different ways to split the input.
Hi, Mike McCara from British Columbia. I have a friend back home that's watching this, and he texts me a question for Unitec. What is the capacity per hour of your system?
The capacity of our system is based on number of fruits. It's not, during the presentation, we talked about the difference between a roller sizer and a bulk sizer. So it's a matter of a calculation based off the speed of the carriers and the percentage of filling rate or cup fill that is ideal to determine the number of fruits per hour that you can inspect. So this is a math that can be done, and it's not, we do not tell a pound per hour capacity, not because we don't want to do it, but because depending on during the season, on the average size of the fruit, you can start your season with a certain capacity because the fruit is smaller, and then during the season, you will see your pounds per hour increasing because the fruits tends to begin bigger. So we cannot tell this is a constant pound per hour rate that you're gonna get because it's not true. So if somebody tells this is not explaining the process, in my opinion.
What is the number of fruits? Bodke from South Haven. So what is the number of fruits?
So we can tell that our carrier goes at a speed of 36 sectors per hour, and we recommend an average cup fill of 70%, which is for us the ideal for this type of product, the blueberries. Of course, what happens after this is not that the system falls apart. It's something that still is manageable. Of course, the more you increase the cup fill, the more fruits are touching each other and possibly not allowing to do a good sorting.
Hi, I'm Andrew Mayman from Campo Sol, Peru. This question would be for any of you. In terms of design and taking into account such issues as constraints on space for all-in solutions, turnkey, what are the pros and cons or the dilemmas that you see with regards to having the sorting and the filling functions all together, flowing together, or being separate processes?
So you mean whether if it's better space-wise having one-step process or two process? Is that the question?
Correct. Pros and cons.
But for my perspective, for what I've seen so far, it's a matter of how you want to manage the fruit. Because if you do a two-steps process, so not a direct to pack, of course, you will have to handle the fruit twice. So it will have to be pre-sorted, so like a pre-grading, pre-sizing in totes, and then will have to be packed separately. It's as good as you feel good with the double handling, and probably is more flexible because you're not locked in with fixed drops. So you can just pre-grade the product and then pack it separately. So you're not, let's say, putting together the efficiency of the grading and the efficiency of the packing. They are not influencing each other. So the grading is grading, the packing is packing. But on the gentleness standpoint of view, probably the direct pack is the most gentle. But
I would like to say also that it depends on your markets. If you are more local market, domestic market, or export market, it depends on your logistic operations. If you pack to order, or if you, it depends on your operation down the line after the sorting operation. So, because if you don't want to get stuck with clamshell that you pack out of the sorting machine, and you cannot do anything about it. So that's also based on how you operate, logistically speaking. If you are more export, local, it's a whole.
Yeah, I guess the other component of it, your question was directly targeted at space in reality. If you're putting your filling lines in a separate area, then you've got to take care of movement between those lines. You also need a way to load them on as well, and that can take up more space as well. It can also affect the efficiencies of what's going on there.
I think we can have time for one more question. Yes, two more questions.
I had Shelley. Hi. As we see more and more mechanical harvesting in our industry for fresh market, I heard some of you guys talk about how the machinery or the technology handles the foreign material, but I also heard some people not mention that. So I was wondering if you could kind of touch on how it would handle and see in the single lane sorting foreign material and also in bulk sorting.
Okay, just on BBC's behalf, we've talked today about a specific sorting machine. This machine has to be loaded in some way, and prior to the fruit getting onto the machine, there's different options for how you can deal with the fruit based on the state of it. One of the more common approaches is to use a blower cleaner, for example. In our particular blower cleaner, we actually incorporate a roller system that can help remove sticks and any other larger material as well. And then it's also very common to use a gap-sized eliminator, where any of the really smaller material that's not blueberries, smaller than blueberries, or the really tiny blueberries or leaves or anything else may also fall through as well. So that's some of the ways that we're dealing with that.
And for what I can tell about our technology, as you were saying, we also incorporate blower systems and eliminator sizer to remove flowers, leaves, and sticks as much as possible. And whatever gets through the machine normally is ejected at the end of the line as not a blueberry. So whatever is not detected to be as a blueberry is rejected, as I said, at the end of the machine. But this is not, let's say, a foreign body detection.
So I'll speak for, I guess, the bulk system. First of all, I think consistent with really any type of sorter, I think it's great when you can try to eliminate as much as possible mechanically prior to the sorting system. This is clear. You know, even though you have the sorter, things work a lot better when you really try to present to the sorter the fruit cleaned up as much as possible by mechanical ways, you know, upstream. You know, but on the bulk sorters, we can target, in fact, specifically the foreign material. So, you know, we will still get very, very low because the product has been cleaned mechanically, but we will still get some percentage of foreign materials, which can be the usual suspects, can be, you know, sticks, leaves, can be insects, of course, as many of you know. And we have classifiers in the sort recipe that are specifically aimed at those foreign materials. And because of the fact that this foreign material can be different size and shape physically than, obviously, than the berries, then we also have sort of smarts in the system to be able to target with the air blowers based on, you know, how many we fire, for how long we fire, how much pressure we have in the manifold, so that we can differentiate between maybe a heavier foreign material like a rock and a lighter foreign material like a small piece of twig, and so that we can ensure that we can have a sort of a positive removal of the FM after the sort.
Yeah, I would echo exactly what you've said. We can create categories, create programs for anything that's not a blueberry. So if you have a weird thing coming through, like a tip off a picking head off the rods, we can see those as well. Sometimes they show up better in IR, but we typically do the tests, and we'll set up a program for that.
So yeah, I completely agree with what you said. And one more thing with the rollers type of sorting machine that's very important is to avoid having any clusters on the rollers, because if you have two pieces of berries that are tied together with the stem, for example, it will not do the job because it's going to get stuck on the sorting machine. So what we are doing also with one of our customers is using one of the bulk solution sorting machine to eliminate the green and the black stuff, so the sticks and also the clusters, before it's going onto our sizer. So that's how we pre-filter before we got the fruit on the sizer. So that's one way also to eliminate the clusters that you can get more by mechanical harvesting compared to manual picking.
Well, I would like to thank each of you for coming here today and participating and asking and receiving all these questions. You will be here the whole day, so probably if you have more questions, you can approach them during the day. Thank you very much.
Okay, we're going to change the focus a little bit now, although not really. But we are going to a single speaker as opposed to the panel approach that we've had so far this morning. The last speaker before lunch, his name has been mentioned many times this morning, so he really isn't a stranger to us, although some of you may not have met Fumi before. Fumi Takeda is a researcher for the USDA Ag Research Service out of Kearneysville, West Virginia. I know that sounds like an odd place to some of us that does small fruit, but he's been active researcher in the small fruit industry for some, 35 plus years, I believe. He has numerous publications and work. There are a lot of patents and innovation that he has his name on, but as you've heard from some of the mechanical harvesting people, he also has his fingers involved in a lot of the advancements that many of them are making as well. So we're very, very pleased to have Fumi here. He's part of a multi-year, multi-million-dollar blueberry harvesting program, and he's going to give us an update on that program and some of the work he's been doing for blueberry. Thanks, Fumi.
Thank you, Rod, for that introduction. Good morning to you all. So this morning, I'd like to talk to you about the projects I have been involved in the last 10 years or so now. And all these projects have been, well, 2 of them have been funded by USDA, National Institute for Food and Agriculture. And between the 2 multi-million-dollar projects, we had a support from the USHBC to develop the BIRD, or Blueberry Impact Recording Device, that we use to analyze packing lines. Although we were interested in using to analyze mechanical harvesters at that time, but they switched to us to work more on the packing line. So today I'm going to talk about what we have done in terms of analyzing packing lines and what we have done to improve some parts of the mechanical harvesters to deliver fresh market quality blueberries, blueberries that could be cold stored for several weeks before reaching consumers. This morning, a number of people have talked about mechanical harvesting blueberries. That's doable. And they talked about pack-outs. But we're talking about 1 or 2 days after harvesting. But what happens to those machine harvested fruit after 2-3 weeks in cold storage? So we would like to develop a system that could maintain high quality even through cold storage. So the project I'll be talking about is a project led by Charlie Lee at the University of Georgia. And I kind of headed the mechanical harvesting portion, but there's 12 or 13 other people involved in this project to look at various aspects of production systems. So I looked at mechanical harvester component design and did field testing. Charlie led the part on sensor and instrumentation development and field testing to measure both the impact that the blueberry encounters during mechanical harvesting and in packing lines. And also, we looked at new ways to analyze bruise in blueberries. So there are other objectives in this project, one that involved blueberry quality, safety, and that involved microbiologists doing the assays to look at amount of microbes, bacteria, yeast, and fungi on various parts of the packing line equipment and on the harvester surfaces. We also had an engineer that specialized in ergonomics, and he did the time motion analysis and other strain on our bodies during harvesting operations. And of course, we have economists working on the cost and benefits of all these harvesting systems. And then we have a large component involving extension specialists across the country to do the outreach efforts to deliver the information we develop to growers and other people in the industry. Before I go on, I'd like to just acknowledge that I follow a couple of very excellent agriculture engineers that have worked on blueberry harvesting and other berry harvesting technologies over the years. That's Galen Brown, who was at East Lansing for many years, and then Donald Peterson at our research station that developed a number of wonderful mechanical harvesting technologies for fruit crops over the years. So for harvesting blueberries, of course, we know that berries could be harvested by hand, which delivers high quality fruit. But as we all know, cost of labor is increasing and labor availability is becoming a big concern to growers. And so we're looking at other ways to harvest blueberries while maintaining high quality and high capacity of harvesting systems. So we heard about semi-mechanical harvesting systems earlier using these platforms, like shown in the center, the Easy Harvester from BBC. It's very good for small berry plants. And there's also concern about bruising when you use this type of a harvest A system, because the machines delivered to you from the factory will have very hard stainless steel or aluminum surfaces where the berries that are detached by hand or by handheld shakers fall. And if you have big plant, berries will fall 36 inches or 48 inches onto these hard surfaces, and that leads to excessive bruise damage in the fruit. And then we had heard from all these manufacturers about the over-the-roll mechanical blueberry harvesters. They certainly have high harvesting and handling capacity because everything is mechanized. But many fruit that get harvested by machine will have poor quality, and they tend to have excessive bruising or internal damage. And bruised fruit cannot be cold stored for a long time in cold storage. So back to sensor technology. So Charlie Lee, back in 2008 or so, was asked to develop a small sphere that could measure impact. Up to that point, there was a huge one that was the size of an apple, to measure impact in apple packing lines. But there was nothing small or size of a blueberry and have a higher sensitivity at lower impact level to help us analyze harvesting processes and what's happening in packing lines. So these sensors have a triaxial accelerometers that measures motion and registers measurements it takes as gravitational acceleration or G value. Okay? So the generation 2 or bird 2 that's shown here is about the size of a nickel, and it weighs slightly more than a large blueberry fruit, but it gives a good approximation of what blueberry fruit faces during harvesting and in packing line operation. So one of the things we did in 2008 and 9 was to attach these sensors on the blueberry plant and then run a number of mechanical harvesters that were available at that time. And we also did video of to record where the sensor moved and dropped during the harvest operation. And then, so we were using the video versus impact measurement recorded by the bird sensor. And we divided the harvesting process, in the case of a rotary harvester, to 3 phases. Before actual detachment from the plant, and then next fraction of a second where blueberry sensor fell through the whirls of shaking rods, and then after it contacted the fruit catching surface at the bottom of the machine. And then this dead space is when it's actually in the conveyor belt moving back to the back of the machine. And then the final phase here is where the sensor actually dropped into an empty lug. Okay? So during this process, the bird sensor recorded 2,000 data points every second. And you can see that one huge value recorded here, that is when that sensor hit the hard catcher plates on the machine. It was the plastic catcher plates. And there's not much impact recorded before that sensor hits the catcher plates. There might have been some interaction with the whirls or the rods, but the impact that it registered was not that high. And the big impact occurred when it actually hit the catcher plates. And then there's, like a blueberry fruit, it bounces a number of times before it rolls into the conveyor belt, so it recorded those bounces. And then another one was when it dropped into the lug. In the case of this machine, it was a VEI that dropped into a lug at the back of the machine, so there was about a 15-inch drop. So this value is recording that 15-inch drop into an empty lug. But as you can see, major impact point occurs when the fruit hits that hard contact point surface. So we also used a sensor to analyze packing lines. We did about 20 in the States, and then we did some analysis done in Chile in 2014, and the USHBC and the Chilean Blueberry Committee acquire additional bird sensors, and Andres Armstrong and his team did additional 100 or so packing lines in Chile. So I'll give you several examples of the packing lines we analyzed. Here is number one up there. Has a electronic sorters in the line, but there were three points in the line where drop was over 12 inches to 18 inches height to a hard stainless steel surface. And then sensor or berry dropped another 9 inches so into the hopper, stainless steel hopper that's on top of the clamshell filler. So overall, there were over a meter or 40 inches of drops in the packing line. Another one, very simple packing line in Chile. There were 4 or 5 transition points, but each one of them was only like 6-inch drops. And then there were others there, all sorts of packing line with different equipment configuration. But we could see from using the sensors that there was a major transition point that generated a lot of impact. That was right after sphere coming out of the electronic sorter and then landing on the grading line. There was a big drop, so sensor recorded. Values high enough to cause certain amount of bruise damage in the fruit. And also, again, when the berries drop into an empty stainless steel hopper, there's a 12-inch or more drop there hitting that slanted steel surface. And that's another point where a bruising can occur to the individual blueberry fruit. So lots of the Chilean growers, packers, have now lined these hard stainless steel surfaces with rubber and no bruise padding. So back to field operation where I did much of the work. 2015, 16, we did work with these semi-mechanical or harvest assist platforms. Shown here is a study we did in Michigan with Randy Baldry and his team at Michigan State. What we have learned from these studies where we use platforms and handheld shakers like a Campanola olive shakers is that there's a good way to shake the fruit off the plant, and there's a bad technique you could use to detach fruit from the plant. And then we learned that if we modify the fruit catching surface with softer material or installation of certain material in a particular way, we could reduce bruise damage in fruit, because when the berries detach from the plant and fall directly on the stainless steel surfaces over, say, a drop of 60 centimeters or so from a mature plant, that is going to lead to internal damage in the fruit. And what we like to see in these platforms, and I think GK Machine is going in the right direction, is that we like to have some kind of a powered fruit conveyance system built into like a GK Machine. And of course, something like this could be self-propelled or should be pulled with a small tractor, so that people who who are doing that harvesting and then manually handling the fruit into lugs wouldn't have to do the action, pushing the machine down the row. And with some of the copycat versions we used, it was kind of difficult to push that harvest frame down the row without problems. There was a problem of pushing and positioning the catching surface right up to the base of the plant. So there's a lot of room to improve in this kind of system. And if you throw in these power hand shakers, you can increase the harvest capacity to up to 15 times or more compared to hand harvesting in some of the studies we did in 2016. So what we did in 2017 is that we kind of moved away from the rudimentary harvest assess system to doing something more mechanically involved, and also to change the fruit catching surfaces to minimize bruise damage. One was to put an intermediate fruit collection surface on the platform to reduce the overall drop height. And then we also changed the design of the catch plates that we installed at the base of the harvester. Involved trying different materials like neoprene and other petroleum-based products. And then we still used handheld shaker operated by workers standing on platforms built on the side of the tunnel. So in 2017, we used the Oxbow over-the-row harvester, and then Oxbow did a number of modifications to its machine. It took out the two rotary heads, and then installed these modified fruit catching surfaces. And since we're doing research, we compare left and right. And one side, we left the hard plastic catcher plates, but we added additional fruit collection surfaces to minimize drops and to reduce impact. And then here's a close-up of the workers. Here, I guess this was taken in Stockton, California, operating these Campanola olive shakers. In later studies, we also modified the olive shakers by reducing the number of tines on the shaking head. Also, instead of having two set of tines when reciprocal motion, we took one out so they were just going like this. Because when you had two set of tines going in opposite directions, it kind of pinched against the branches, and we could not get the tines to maintain this certain vibration. So we reduced the number of tines, and that helped to improve the harvest capacity. So here are some of the summary from the 2017 studies. Studies we did in Florida in springtime, and then we moved the machine across the country to California, and then was moved again to Oregon, and finally to Linden, Washington at mid-August. So we did harvesting of a number of southern high-bush cultivars like meadowlark and farthing. And on the West Coast, we harvested northern high-bush like Duke, Aurora, Draper, and Liberty. And in all these harvesting trials we did across the country, we've learned that with using these over-the-road machines and handheld shakers with, say, 4 operators on the machine, we got good amount of fruit per hour. And we had one worker at Munger's Farm in Lodi who got more than 800 pounds of fruit detached in an hour, but as compared to about 30 pounds that hand pickers can do in an hour. So there's a huge improvement in the amount harvestable fruit in a given hour. Of course, we have to maintain the harvester at a slow speed so that the hand operators could keep up the harvesting. And we kept the machine at less than a quarter of a mile per hour. But as we increase or improve the harvesting technique, and maybe we provide more incentive for these workers to maintain high capacity, then I think the machine could be operated at slightly higher ground speed. So overall, we were very pleased with the quality of the fruit we harvested with this experimental harvesting system I have described. So, you know, with the research system, we got a lot of fruit that looked like this, as good as the hand harvested. And this compares to a lot of the fruit with internal damage when you machine harvest blueberries using conventional, commercially available machines. But as you know, not all firm fruit is same. There's firm fruit with no internal damage, and there's firm fruit with certain amount of internal bruise damage. And this is kind of damage you'll get when you use conventional over-the-road machines. High percentage of fruit will develop this type of damage. And those fruit cannot be cold stored for a long period of time. So machine harvested blueberries may look like this, fresh packed, go into clamshells, and then delivered to consumers. But when you look at the inside of machine harvested fruit, some could look like that or this. And we have not, we started the project in 2014, we were not aware of any technology that could detect and quantify internal damage, okay? So Charlie Lee used the hyperspectral imaging system to be able to tell us which is bruised and which is not bruised fruit. Shown here, what happens with this technology is that a fruit with no bruise would have develop this kind of image based in his software. And then the berry that had a certain part of the fruit bruise would show up with this red color. So we could visually now see what fruit looked in the inside. So this is a kind of method that other sensor people have talked about to detect and quantify and sort out bruised fruit, okay? So his technology involved looking at the fruit from visible to near infrared to near to far infrared. And the wavelength that was particularly interesting to detect or discriminate non-bruised fruit from bruised fruit was about 1,065 nanometers, which is in the near infrared wavelength. So using that kind of technology, we're now able to discriminate non-bruised from bruised fruit. So that's it. Thank you.
You're going to be around through all day today?
All day today,
okay.
Yes.
I know it is pretty much lunchtime, and so we will not take questions right now, but Fumi will be available. So thank you again.
Yep,
appreciate it. It's a really interesting project, and there is a lot of additional research, as Fumi pointed out, coming out of that.